with the best from Kaunus Technical University to share their experience with our AI module and their experience with AI in the power grid. We would like to inform everybody that we are also recording this session, and if you have any questions, please provide questions in the commentary box, and hopefully we are able to go through some of them at the end of our presentations. We do have to bear in mind that we only have a 60-minute time slot. If you have any additional questions, the contacts are in the invitation, and of course we'll send out the recording as well. And I hereby would like to introduce you to our expert panel, head of the Electric Power System Department at Kaunus Technical University, Professor Saulius Kūčius. With more than 100 publications on the matter, Professor Antanas Verikas, Senior Analyst and Engineer at Lithuania's TSO Litgrid, Mr. Aivaras Livikas, and Engineer and Expert, Mr. Jonas Vaičius. Thank you very much. This is my introduction, and please, Professor Saulius Kūčius.
Thank you. Good morning. Thank you, Carl, for introduction, and welcome to our webinar. Good morning for our partners. Good morning for our colleagues. And today we would like to introduce and present our model, which is titled Artificial Intelligence in the Smart Grid, which was developed as a part of Smagrinet project. And first of all, I will make some short introduction about this model, about the general idea, and then ask my colleagues, Professor Verikas and our PhD student, Aivaras Livikas, to introduce our model in more details. So I share my screen. So, the idea of this model comes to life from the understanding that the modern electric power system are in the transition process. So the problems of the efficiency, problems of the electricity market, and the problem to keep reliability of the electric power system. It's big challenges for the modern power system between a lot of different new generation sources, and the challenges that comes from the electricity market should be solved in proper way. So the one tool which can be applied for this problem solution can be artificial intelligence, which allowed to solve very different and very challenging problems, not just in electric power system, but in other field. And the big experience from the other field of applications can be moved to the energy systems applications and be applied very efficiency for the good, or for the consumers' good. As you know, electric power system is a very complex system, and artificial intelligence are as a growing new technology, as as indicated by the wide variety of applications such as remote sensing, control forecasting, pattern recognition, and other application fields can be used for the solving of the problems of electric power system. The main reason for this growing activity is the ability of artificial intelligence to learn complex non-linear relationships and their modular structure which allow parallel processing. Artificial intelligence has been shown to be useful in solving algorithmic type problems, and more importantly, in dealing with problems for which algorithms are not available, but significant data is at hand. So the data processing is one of the key and the most interesting application field, which can be applied for the solution of the problems of the modern electric power systems. As our department has long experience in application of electric power system application of artificial intelligence in electric power system, we understand that the knowledge and understanding how to apply artificial intelligence is very important for the electric power engineers. The first dissertations which were related to artificial intelligence were defended in our department in 90s, and they were dedicated to very important field of electric power system, and their content was dedicated to predictive maintenance and consumer behavior. So having this understanding, we integrate our new model into the master degree study program. And this model brings a good basis for the students, good primary understanding for the students about the artificial intelligence, and the knowledge which what students getting in this model, they can apply in other model, and this experience, according to our understanding, is very good, and students like it, this model, and young people understand that the future is an application of the modern technology into the power system to solve the challenges which come from the energy system transition. So it's my short introduction, and now I would like to ask Professor Verikas to continue our webinar and to introduce the content of our model. Thank you. Dear Professor.
Yes, I'm online, but I think I need to.
Welcome to the webinar, and please share your slides.
So good morning. My name is Antanas Verikas, and I will give you some details about the model, some insights, some short highlights about the model. So objectives of this model is such that at the end of the model, you will get knowledge of these data types and the data representation, information about main machine learning and data mining algorithms used in smart grid related tasks. And also you will get numerous examples of applications in smart grids of artificial intelligence methods. So about the structure, it looks like this. So we give some lectures, it's 8 lectures, but this could be adjusted. 8 mean 8 for times 2 hours. We have seminars, presentation of project results. These seminars and presentation of project results works in groups, and we have discussion. So this is how the model looks. So now content of the model. So we start with this with benefits. We emphasize that AI is very important in smart grids, and then we talk about data types, data representation, exploration, visualization, since it is very good to have understanding about the data. Then we talk about models, linear and nonlinear models used to solve different tasks in smart grids. We also talk about deep learning, which is very popular now and very good results in some tasks. We talk also about unsupervised learning, which is where you don't need to provide information about the data from a teacher, from a human being. And we talk very important questions about model assessment and selection, how to assess model, how to select the best model you designed. And then the remaining part of the course of the model is given for different applications. So we talk about applications in different fields, for data management, for demand management, for load and power prediction, for yield optimization. Then we talk about consumers and consumer insights, how these techniques can be used to get information about this. Then about predictive maintenance, using different data from different sensors. Participation in energy markets, how to optimize income when you participate in energy markets. Then we talk about SCADA system and energy management systems, how these systems should be designed and how artificial intelligence is used there. Cybersecurity, power system protection. And also I give a few examples from my previous work. I was at the Center for Applied Intelligent Systems Research. This center was dedicated mainly for predictive maintenance with Volvo company, but also one of the directions was this smart grids. So we start with this question, what is AI? Why to use AI? So we say that AI system should demonstrate at least some of the following behaviors associated with human intelligence, like planning, learning, reasoning, problem solving, knowledge representation, perception, and acting in complex environments. This is just some of those intelligence features. But we emphasize here learning. Learning is essential. It is essential for human beings and also essential for systems where artificial intelligence is applied. So what benefits we can get using smart grids? We emphasize this for students. So we say that artificial intelligence, to apply such kind of techniques, you need some prerequisites, like you have to have algorithms. If you look here on the right-hand side of the image. So we need advanced algorithms. We need computer power and we need big data. So these 3 prerequisites if you want to get some benefits from such kind of techniques. And now in smart grids, we have all these prerequisites are fulfilled. So we have powerful algorithms, we have computer power, you can get quite a lot of computer power, for example, in clouds and so on. And we have data, we have a lot of different data. So then AI can aid energy sector in different ways. I list here, provide some list. Of course, it's not the final list, but demand management, load forecasting, then the prediction of wind power or solar power, yield optimization, balancing, power market, energy trading, consumer consumption insights, predictive maintenance of different kinds, and also tackling cybersecurity challenges, power system protection. These are just a few examples. More areas where artificial intelligence can be used and can be very useful in smart grids. So we start then talking about data. We emphasize that you can get different data. You can have just one measurement, like a scalar X. You can have several measurements. Then you group those into, usually group into a vector, like this vector X. You can also put the data, many vectors, if you can put into a matrix. It's more convenient than to do some analysis. And also you have this data set. So we emphasize this, that you know what the difference is between these types of data, this representation of data. But we also talk about the fact how data looks like when you measure, you get like these data time series here. It could be load, it could be temperature, it could be other measurements made. But you can also get images, as you can use more and more images now in smart grids. On the bottom of this figure, on the left-hand side, they have this load across different months. And here you have this hour, so you can put this load in this way and you can get as an image. And then you can apply advanced image analysis techniques to extract information from it. On the right-hand side, you have image from the sky. So this is such kind of images are used, for example, for predicting power from solar panels. So since it's very sensitive, you have clouds or don't have clouds. So using these images, you can get better predictions. So we emphasize this, that data could come in different forms and you have to deal with this. Then we start talking about models. We talk about linear models for prediction, linear models for classification, and then we talk about different nonlinear models for prediction and classification. I just list there some types of models like multi-layer perceptron, support vector machines, decision trees, random forest, and kernel methods. And on the right-hand side, I just show an example of this, of a random forest, which is very good model, nonlinear model, and easy to understand, and produces good results. So you may guess that this forest consists of many decision trees. And we talk about deep learning, which is very popular. And I showed here what is deep learning and what is the difference between traditional learning and deep learning, and traditional machine learning. So here is a sketch of this traditional learning. When you have, if you want to recognize, is it a car or not a car? So usually a human being extracts some features which characterize a car, like for example, that you have wheels, that you have windows and so on. And then those features are put into a system, a neural network, for example, just a structure of processing elements. And then that structure tells you, you train this structure, you present many images to this structure, you train it, and then you can get an answer, is it a car or not a car? But this human being is a lot of work for a human being to extract those features. And this is quite tedious work, and you need an expert in that field. So the main difference between this traditional learning and deep learning is that in deep learning, you don't need a human being to extract, to tell what the features an object, in this case, a car. So it's much easier to design, and you have this, the whole structure, you can optimize the whole structure here, so-called feature extraction classification. So I just show an example that you understand what is the capability of deep learning. This example tells was the development during from 2010 until 2015. So this is the, on the top you see this, the classification error of then you classify images where you have 1,000 different classes. So 1,000 different classes, like for example, a car, a chair, and so on. So you see when started, this is shallow structures, not deep structures. So there was 28% in 10 and 11, 25%. And then at 2012, we got results from these deep networks. So with 8 layers, so 16% dropped to 16, dropped to 11% next year, then to 7%. And this on the top, you see how many layers we have here. So those structures, deep networks, they became more and more complicated, but the results also better and better. And in 2015, you see that the result is just 3.5% errors. And while a human being on that task makes about 5% errors. So you see that such networks, they are better for some tasks than human beings. Then we switch to unsupervised learning. Unsupervised learning is used to explore the data, to find some, I write here, order in the environment. Order means that you can detect clusters like here and here. Then you can start to try to understand why you get clusters, what those clusters mean, and so on. You can also get some directions along which data perhaps more gathered along some directions. So this is data exploration and understanding, really, and supervised learning. We talk about that also in the course. And then we switch into these very important questions concerning model assessment and selection. We talk about this so-called generalization error, model generalization error, which is error for new data which have not been used to design the models. So, and this error usually is split into three parts, so-called bias and variance, and this is just noise. So here is the picture showing, allowing to understand what we mean with low bias and high bias, low variance and high variance. So this in the middle of that, this circle shows where our predictions should be, what we desire to get from our models, what prediction. So this target value in the middle. Then you have low variance and low bias. So all predictions are very close to this, what we would like to get. So this is low variance and low bias, but it could be that you have also low variance, but you are quite far away from the target value. So in this case, you have high bias and low variance. And also you can get this high variance and low bias if you look into this figure. So you see that on average, you will be accurate. You will be in the middle of this figure on this in the red circle, but you are quite scattered. You have high variance. And this is the case where you have high bias and high variance. So you are high variance here, the predictions are scattered, and also you are quite far away from the desired target values. So this shows importance, how to assess and how to select models that you would like to have low bias and low variance, and how to achieve this, and how to select the best model. These are very important questions in the course, and we talk about this. And here is an example that how this bias and variance depends on model complexity. So we also tell students, so we have here on this x-axis, we have complexity, here we have low complexity and high complexity. And if you look, this is the prediction error. So usually when you get data to design a model, you split the data at least in two parts, training sample and test sample. Test sample is not used to design a model, but used to test. So if you look, so here, so it's for training sample. So if you increase complexity, model complexity, so prediction error decreases. But it's not such, you don't see such behavior on the test sample. you have some minimum point. So there is optimal complexity. So you choose model of optimal complexity. So you want to get good model not just for training data, but for test data you haven't used to design the model. So these questions about issues we talk in the model. Then we switch to applications, different applications of artificial intelligence. And here I will show you just a few examples what we usually talk about. So this is one is a demand management application for the energy, demand management. So you have here a red dashed curve is initial demand, and this the blue dashed curve is the final demand pattern. So this is the task here is to flatten these demand peaks. So you don't want to have these high peaks in demand, and then you see this artificial intelligence can help you to achieve this task. So this is the blue curve is the final load pattern. And on the right-hand side, we see this load factor. So load factor is the ratio between this average, between the average load and maximum load. So you want to have it as close as possible to 1. So you see also in when time goes, you do train the system, and it's better and better in that sense. Then it's an application for load forecasting. So it's an example how good we can be to forecast load using nonlinear model, in this case random forest. Here I show the example how we can forecast this solar power generated from solar power plant. So this is predicted red, and observed this is blue. So it's quite good prediction. And here you see these prediction errors in the middle, and this distribution of prediction errors, which we expected, we want to be quite close to Gaussian here. And here is application of this to get some insights in consumer insights. So you can build, using these technologies, you can build a system for consumers. So you have this smart meter data, you have a database. You can also put meteorological data like weather, calendar data, price in time of use, and then do some data pre-processing, then data exploration. You can look into consumption patterns and so on. And also you can build models from that data, for example, to predict consumption, to predict different things. So you have using those data. So we talk about this also in the course. Then one more example is about energy market, how to use these techniques to optimize income. In this example, we try to optimize income from power plant. And we have here deal with 3 markets: this day-ahead market, intraday market, and balancing market. And this designed a system optimization system that you would like to have to optimize income from that system. One more example when you can build this energy management system. So if you look into this picture, so what we have here, we have this solar panel, we have energy storage unit, then we have this load saving utility. And also what is interesting here, so we have these electrical vehicles which could arrive in random time and try to connect. So in this example, those vehicles can consume energy, but also can be used as energy generators. It can provide energy to the grid here, energy injection to the grid. So and then using this energy management system, then you are able to deal with this uncertainties which arise due to this solar panel power generated from solar panels, since it depends on weather conditions. And it, in this case, was studied what could you gain something using these electrical vehicles. to, for example, as energy generators, and also how these uncertainties change the cost of the system if you deal with these uncertainties using artificial intelligence methods or not. And these are the findings that if you disregard the uncertainties, so the cost can increase about 370%. In this case, is quite a lot. And this is on the right-hand side, I have these different scenarios, how much power can be generated during a day from solar panels. So using this artificial intelligence approach, they use this information that this not just some kind of average. Usually you use average power generated from solar panels, but in this case you can have different scenarios, and including using those scenarios, you can reduce your costs. And also they studied that can you get some benefits when you use this energy storage system, and they found that yes, it's a good thing to have this energy storage system in that energy management system. And the last example is from this center from Sweden. We had very good relations, and I worked there for quite a few years there. So, and one of those directions there is the energy smart grids. And this is an application where this streaming for stream data cleaning for dynamic line assessment. So if you look in this figure, you see these different sensors like a temperature sensor, weather sensor, and weather station. And this information is used to you can shut down those lines if you get this information that the temperature is too high. So, and these techniques were designed, you can then use data, you get data online. So it's you can derive constraints obtained from these derivatives of consecutive data, but also we use these association rules, which are generated automatically from historical data. So by combining those two sources of information, you can get quite good results. You can correct these measurement errors is presented here. So these are peaks, these are measurement errors, and these are corrected data shown in red. And the last slide I have this application. So it's this application of techniques in district heating. So it's a different field. So we also you can gather data, and we use this district heating to look into these substations, how those substations function, and then you can. This is data collection, data pre-processing. Then the collected data are analyzed by applying these clustering techniques, and the patterns are discovered there. And then these different call flow strategies are developed based on this information obtained from this data clustering. So this is an application of artificial intelligence techniques in district heating. So that's it. That was my presentation, how our course looks like.
Thank you.
Thank you.
Yes, I would like just to add that the content of the module is created in consultations with Lithuanian energy companies. So Lithuanian energy companies is highly interesting in this field, and the young engineers who understand the artificial intelligence are welcome in these companies, and they see that the future of the energy is the artificial intelligence is a part of the future of the energy system. So the next is Aivaras Livikas, he will present the practical part of our model. So Aivaras, please, welcome.
Hello everyone from rainy Lithuania. I hope that you can hear me. And now I will present the application in smart grids using the artificial intelligence. So basically, what we do, we divide the energy system problems into 3 types where we can apply artificial intelligence solutions. So the first type is the prediction type problems or the forecasting problems. So basically, we would need to answer ourselves the question, can I predict when this equipment will fail, for example? Or can I predict the solar generation? Or can I predict the wind generation? So those are the type of the prediction problem types. Another type is the classification and clustering type of problem. So over there, for example, we can ask ourselves a question. Is this customer different from another based on the data I have? Or is this customer an energy thief? Or is this customer is likely to buy one of our services? So the classification or clustering problems can help, artificial intelligence can help for these problems to solve them. Then we have an optimization type problem. So for example, we ask how to schedule a PV power plant and energy storage unit to get the maximum profit, or what's the size of the energy storage unit should be. So further, I will show you a couple examples of each type of the problem, and I will show you the examples which artificial intelligence can solve. And for each type of the problem, I will show you one more detailed example. So the first one is a prediction, as I mentioned before, or forecasting. So everybody, since the early days, wanted to be an oracle and know the future. So as I mentioned before, so renewable energy sources generation forecasting is very popular, and a lot of companies are providing services deploying artificial intelligence in order to forecast wind power generation or solar power generation. Another one example is the energy consumption. So for the energy consumption, we need to collect a lot of different type of customers' information. So everywhere what is associated with artificial intelligence, collecting data is the key. So the more data you have, the more conclusions you can make from it while deploying artificial intelligence. So for the consumption, artificial intelligence can help you to divide customers into different types. For example, there is a factory, there is a store, there is a household customer, and give you the forecast for different types of customers. It also can help you to forecast the energy system losses, the transmission system or the distribution system losses, which occurs to system operators. The fourth one is the energy system imbalance. If you're an energy market player, you might want to forecast the energy system imbalance and base your actions upon that forecast. And of course, you might want to forecast energy prices, but for that you need to have a very good knowledge what impacts the energy price. And of course, you have to have a very good quality data set in order to forecast the energy prices accurately. So for the more detailed example, I took the wind generation forecasting example. And over here, you can see that if you would like to forecast wind power generation using artificial intelligence methods, for example, deep neural network, what could be the input? What could be the input? And then you put this input into the deep neural network, and it gives you the output, which is the forecast over here in red, and the blue is the historical data, and the black is the actual data. So let's go from the historical data and the future data as well, the wind direction, the historical data and the future data, the temperature, the wind speed forecast from different providers. So you can buy if you want more accurate or forecast for a specific location. You can just download it freely if you find such information online. Of course, you can also use the neighboring countries' wind power generation in order to get more accurate forecast of your wind power farm. Or you can, if such information available, you can try to get near wind farms generation output. So this could also help you to get more accurate forecast. Okay, then we go to the classification and clustering examples. So as Professor Tanis mentioned before, the predictive maintenance is getting quite popular in the application of artificial intelligence. So many of the energy system mechanisms has sensors and they're connected to the SCADA, but it's really hard for operator to maintenance. I mean, to detect all the signals got from SCADA. So it's not always easy to physically see and check all the signals. So this predictive maintenance and artificial intelligence utilization can help to collect the sensors information and provide a signal to operator that you might want to check this or that mechanism in order to prevent its failure. Another example could be the energy theft detection. So energy theft can be recognized from the consumption pattern. It can be identified as a suspicious behavior. So you can check the consumer's consumption pattern, and artificial intelligence could help you to find the outliers or the suspicious behavior and then give a signal to the physical person, and the physical person can go and check if there is an actual electricity going on. Third example could be the customers clustering, which I'm going to talk about more in the next slide. So this is basically division of customers into groups without predefined groups. So you don't know what customers you have, but you got a lot of information about your customer, and you can divide it those customers into groups, and I will tell you later what you can do with those clusters. So, and the last example from the classification and clustering would be the transmission lines or the generator inspection. So you can gather photo or video information from drones going through the transmission or distribution system lines, and later on use this photo or image data as an input to artificial intelligence system models in order to detect the location where the possible failure could happen. So the more detailed example of the classification, actually this is a clustering example. A more detailed example of the clustering could be clustering clients, as I mentioned before, based on their data. So we can ask if this customer has electric vehicle, what's the size of the family of the consumer, what's the home type, is it a type of household, what's the energy consumption pattern of this customer, what's the energy payment type, for example, does customer pay online for the energy or is in a different way? What is the location of the customer?
Excuse me, Ivaras.
Yeah.
May you try not to use the red pointer?
Yeah.
Because
sure.
if the picture moves, then it takes lots of your bandwidth, and we don't hear your voice, to be honest.
Oh, okay. So I've turned off. Maybe it will be better.
Now, thank you.
Yeah. Okay. So for clustering, you can take all of this information, which you can get from your customers, and then divide customers into the clusters with the help of artificial intelligence methods. So, for example, we can say the cluster 0 customer is most likely to install solar PV, and you can provide marketing solution. So, for example, cluster 4 customer is most likely to buy green energy, or the cluster 1 customer needs a new refrigerator based on the energy consumption pattern, which is quite high baseload probably, and the refrigerator is quite old, so you can give us suggestions of various suggestions to your energy consumers if you're energy supplier. Then we go to the optimization, and over here there are 3 examples. So the first one is the energy system optimization. So you can optimize the control of the various connected energy sources, which might be connected to the batteries, and you can optimize the control. You can also optimize the trading when you have the virtual power plant using the optimization and artificial intelligence methods, and you can do the energy consumption optimization, for example, for managing demand side response. So one of the examples could be turning on or off your cooling devices when the energy is expensive, and providing system services with consumption devices flexibility could be the one of the option where the energy consumption optimization can be applied. So now I will go in details through the optimization example, and this is actually the project which we are working on with the university. So there is a 900 megawatt installed capacity hydro pump storage over here, and there is a plan to build a solar PV with a total capacity of 200 megawatts on the top reservoir of the hydro pump storage, and the objective is to apply the artificial intelligence solutions to improve the efficiency. So I will go really quick how we are planning to do that. So in order, first we need to have a very good forecast in order to make an optimization. So we are planning to make a forecast once a day for day-ahead market trading, every hour for intraday market trading, and every 15 minutes for managing the imbalances. So for the forecast, for PV generation forecast for a shorter term, we're planning to capture the sky with the pictures every 15 minutes and measure the radiance with a pyranometer, which is right now mounted on the rooftop of the university, and we collect the data set later on from these images. Artificial intelligence could help to extract the most important features. For example, if we seek to get the more sun, the more radiance, we need to fix our model in such way that it detects the clouds. So artificial intelligence could help us detect the cloud and to give a forecast for a short time of period. And for a longer time of period, we are planning to use the satellite images, which would also work in a similar way as the sky imager, but we would use it for a longer period of time, for a longer horizon. And later on, when we have a forecast, we can put all the forecast information, all the system boundaries, all the other market information we have, and put it in the artificial intelligence model, optimization model, which can help to make a schedule for a hydro pump storage when it needs to load the energy, when it needs to consume the energy. So this graph shows in orange when artificial artificial intelligence system has decided that the hydro pump storage needs to consume energy, and in blue there are hours when hydro pump storage needs to generate the electricity. And here's the comparison, how the hybrid power plant works and how the only hydro pump storage works. So here's the water level, and in black how the water level looks when there's only a hydro pump storage, and how the hydro pump storage combined with the solar works is in blue. So we can see that there is a different pattern, and we get the very different results when we deploy artificial intelligence for optimization, and therefore we can try to maximize the profit of this combination of solar PV plant and hydro pump storage. So many boundaries can be included in such models. So hydro pump storage can be replaced by any other energy storage unit. You just need to change the boundaries. For example, you can change it with the batteries. Solar PV plant can be changed with the wind farm. So in my opinion, the energy storage units are very respected, and I consider it as the most promising area where AI can be deployed. So capacity market is coming. TSOs need more balancing energy to manage the renewables integration to the grid. So AI is the method which can help to solve a lot of issues with the renewables integration, and it could bring a lot of benefits. So that was my last slide. Thank you for your attention.
This is all from us, and we are waiting for the questions.
Thank you very much. The first question actually was provided in the last minutes of the last presentation. In the last presentation, you showed the figure for water levels, but is there a comparison for the profit as well?
Yes. Can you hear me?
Yes.
Yes. So this information is quite confidential now because there is an owner of this hydro pump storage. But yes, we do also the profit and benefit calculation as well, not only the water level changes.
Understood. So you have a contractual relationship with a
Yes.
with a company.
Yeah.
But in between the lines, may we read that you are still doing the research into it? So you have not been cut out of the. So you're still continuing with the research. You have not been dropped.
No.
So that's what we had to read in between the lines. What is the target audience for the module? Bachelor, master, or PhD students?
Oh, the target of the module is the master degree students, and all these projects are dedicated for the master degree students. So, but of course, the PhD students also can apply for this model and get some useful information from it. So it's PhD students are also welcome.
And just to remind that we do have up and coming short-term continuing educational programs as well for the current workforce. But yes, the target audience for the modules are the master students. Can AI be applied to district heating?
Yes, of course. We are talking about all energy system. We not exclude heat energy from the energy system. And as we understand, in the future, this will be system in the system. So of course, heating is also part of this model.
I may add here that the last slide I showed to you, it was concerned this district heating. So we looked into different patterns of this behavior, different substations, and how to then, based on this information, to develop different strategies for controlling that substations and the system.
Which can be the relations between electric grids and heating grids then?
For example, accumulation. We have a very good example in our university where you have 380 kilovolt solar power plant, and we are using heat energy storage to accumulate energy, which we use during winter time for our building heating purpose.
Thank you very much. Which software tools are planned to use for AI implementation and training, for example?
Maybe Professor Verikas can.
So we currently we use Python. It's a very popular tool for dealing with these artificial intelligence techniques. But then when it comes to implementation, then you can have different solutions. You can also use maybe C if you want to. So I think it depends on what you have in your system. But usually we use Python.
Thank you very much. There's a very specific question from Norman Beck. What is the scope of application of AI for the short-time system stability of smart grids or the power grid, especially in island grids? How much of an effect can it have?
Okay, the most important outcome from the application of artificial intelligence, it can be the prediction of the behavior of the system. So you can be able to predict what happened in the next few minutes or few seconds according to the data which you have from the history from the measurement history. So I see the control of the system and application of AI is very important and can be useful for management, especially of island power system.
We have 1 more minute and we'll have 1 more question, but please forward all of your questions and we'll try to answer them if we send back the conclusion of our webinar today. So we'll try to answer these offline via email. But the last question that we're going to take is, what are the biggest challenges when switching an algorithm trained on a mathematical model to a real system? So if we take it from our mathematical models to a real system, what are the biggest challenges that we face?
So usually what you need to deal with is so-called overtraining. So especially if you do not have enough data, if you have little data sets, then you can design good models for training for set, but you can deal with big difficulties when you put it on this in real use if you don't have enough data. So this is could be a big challenge. But now, since this in big data world, usually we have quite a lot of data.
So quite a lot of data seems to be the main.
Of course, it's not everywhere. In some applications, you still lack data.
Well, thank you very much. As I said, the rest of the questions will be answered via email and everybody will see the answers as well. Thank you very much for our guests today. I hope you had a successful webinar from your view. I would like to thank our expert panel, Professor Saulius Kūcius and Professor Antanas Verikas and Mr. Aivaras Līvikas from Lithuania for providing insight. And if you have any further questions, please contact us at info@smagrinet.eu. Thank you very much. Stay safe, and one more day to go, and have a lovely weekend then. Thank you very much, and goodbye.
Thank you.
Thank you. Goodbye.
Bye.
Bye.